Have you ever used a vending machine? Well, if you haven't, you're not really missing out. But let's say you have. And so the vending machine, in our case here, has some buttons on it. It's a very limited selection. There are only 4 buttons on this vending machine. And then it has this dispenser. So let's say you come along, you're thirsty, and you press this button here. Well, this button is called A. You press the A button, and out comes a beverage, a delicious beverage for you. This is beverage X. All right, and let's say your friend Timmy comes along. Timmy's hungry. He presses button B, and out comes a snack. The snack is called Y. These aren't very appetizing snacks, but anyway, so this is what a function does. This vending machine, we can call it F. That's the notation that we normally use. We say F takes an input. In our case, the input was the button you pressed. You pressed button A. That's your input. That's all that notation means. It means you used the function F, and you put the input of A, and what you get out of it is X. And another example. Timmy pressed button B, and he got his snack Y. So that's all that a function does. It takes some kind of input. Takes your input, and it gives you exactly one output. And it's the same output every time. It's not like you're going to go up there and press button A, and then out comes beverage Z. No, that's not going to happen. So every input has exactly one output, and that is an intro to functions. Stick around for more. Remember our vending machine example looked like this. Had some buttons and a dispenser, and you could press one of the buttons, maybe A, B, C, or D. Each letter corresponds to a button, and then you can get some kind of output like T, R, S, V. So a button corresponds to a snack or a beverage. For example, let's say you press button A, maybe that'll give you beverage R, and the vending machine is the function. So this is the notation we use. We say the function f of A equals R. So in this case, the blue stuff is the domain. Those are the possible inputs. And the purple stuff is the range, the possible outputs. So let's write that down. Domain, inputs, and range, outputs. So let's look at a function, f of x equals x plus 2. So you can plug in any real number here. There's no division or square roots to worry about, and I'll explain what I mean by that in a moment. So that means the domain is all real numbers. Domain, all reals. And then the range, since we're just adding 2, that just shifts everything up by 2. The outputs can also be any real number. If you want to test that, just think of a number, and you think, how can I get that number by adding 2 to it? Well, you just pick some number that's 2 less than that. So domain and range are both all real numbers. So let's look at a different example. F of x equals x squared. So again, we can plug in any real number here, and we're just going to square it. That's fine. There's nothing wrong with that. But how about the range? Well, let's think about this. Since we're squaring x, we can't get any negative results. How can you get a negative number by squaring something? Yeah, you can't do that. So the range here, we're going to say the output call the output y. It's greater than or equal to 0. Because 0 is the smallest number you can get by squaring something. Alright, hope this was helpful. Give me a like and follow for more. Thanks for watching. Let's evaluate some functions. Let's say f of x equals x squared minus 3. What's f of 2? We just plug in 2 everywhere we see x, and we get 2 squared, which equals 4, minus 3, which equals 1. So that's our answer. How about the domain of this function? Well, there's no division or square root, so we can plug in any number for x that we want. So the domain is all real numbers. How about the range? What numbers can we get out of this function? To find that, let's replace f of x with y. So y equals x squared minus 3. And now we'll move 3 to the other side. We'll say x squared equals y plus 3. Now remember, x squared is greater than or equal to 0 because you can't square any number and get something less than 0. So that means y plus 3 is also greater than or equal to 0 because they're equal to each other. So y plus 3 is greater than or equal to 0, which implies y is greater than or equal to negative 3. So the range is all real numbers greater than or equal to negative 3. That's what we can get out of this function. Let's try another one. G of x equals 1 over x plus 1. Let's evaluate g of 1. We just plug in 1 for x, and that equals 1/2. How about the domain? Well, we know we can't divide by 0, so let's set the denominator equal to 0. X plus 1 equals 0. And that implies we just subtract 1 from both sides, we get x equals negative 1. So the domain, x cannot equal negative 1. All real numbers except negative 1. How about the range? To find the range, once again we replace g of x with y. We get y equals 1 over x plus 1. And now we do some simplification. We multiply both sides by x plus 1. We get y times x plus 1 equals 1. Now we can divide by y. We get x plus 1 equals 1 over y. Finally, we can subtract 1. X equals 1 over y minus 1. Now notice, there's a y in the denominator, and we cannot divide by 0, so y cannot equal 0. And that is our range. We can get any number out of this function except for 0. Alright, hope that helps. See you in the next one. Can you do functions? Yes, Kanye Ryder, I got you. Let's look at a function. F of x equals x plus 1. We're going to graph this thing. So we'll just make a table. We'll say, what are the x values and what are the f of x values? And let's look at 0. So if we put 0 in, right here, that gives us 0 plus 1, which equals 1. So f of x equals 1. Okay, how about 1? So if we plug in an x value of 1, we get 1 plus 1, which equals 2. All right, how about negative 1? Negative 1 plus 1 is 0. There we go. Let's graph this thing. Make a nice simple graph. So 0, 1. So we stay right at the origin and we go up 1. Let's put a point right there. 1, 2. So we go to the right 1 and we go up 2. 1, 2. Right there. Negative 1, 0. So we go to the left 1 and then we stay on the x-axis just like that. So this is a line, and that is f of x. Very cool. Let's look at, say, g of x equals x squared. Okay, so let's look at x values and g of x values, see what we come up with. Let's say 0. So remember, we plug in 0 here, 0 squared is just 0. So g of x equals 0. How about 1? 1 squared is 1. Negative 1. Negative 1 squared is positive 1 because a negative times a negative is positive. How about 2? 2 squared is 4. Let's graph this thing, Kanye. So we got 0, 0. We got 1, 1. 1, 1. Negative 1, 1. Then we got 2, 4. 1, 2. 1, 2, 3, 4. It's all the way up here. So if you haven't learned this yet, I'm going to tell you that this is called a parabola. So it's not just a straight. We want to add some bend in there. Nice and bendy. And that is a parabola. All right, hope that helps. See you in the next one. If I show you a graph, can you tell me if it's a function or not? Let's find out. Here's the first one. Looks just like that. What do you think? Well, that's the y equals x graph. Is that a function? Yes, and here's why. We can use the vertical line test. Draw a vertical line anywhere on this graph, and we'll see that it will only cross the graph in one place. And that's required for it to be a function. Each input must have exactly one output. Here's another one. Looks like this. What do you think? That's y equals x squared. It's a parabola. Is that a function? Yes, it is a function. Passes the vertical line test. Now notice it fails the horizontal line test because it has two places where it crosses, and that's okay. Let me show you why. If you have multiple inputs, multiple x values that all go to the same output, the same y, that is okay for it to be a function. But if you have one input that goes to multiple outputs, multiple y values, that is not okay. That is not a function. Let's do a few more here. How about this? What do you think? That's a familiar shape, huh? It's a circle. Is that a function? No. And you guessed it, it crosses in two places. Okay, how about this one here? This is the, what is that? That's the cubic function, y equals x cubed. Oh, I just gave away the answer. Cubic function. Yes, that is a function. Because look, it passes the vertical line test. We'll do one more. How about this guy? Looks like that. That's a parabola, huh? Just like here. This one is y squared equals x. Now, is that a function? No, it's not. Because look, it fails the vertical line test. All right. Hope that helps. Thanks for watching. What does it mean to transform a function? Let's take a look. We're going to use parabolas to demonstrate this concept. If you don't know what a parabola is, that's okay. It just looks like this. F of x equals x squared. So what's the domain of this? The domain are the numbers we can put in, the inputs, the x values. Well, this stretches to the left and to the right forever, so any x value we want, there will be a corresponding y value. So we can use any input we want. So the domain is all real numbers, negative infinity to infinity. How about the range? Well, notice the lowest point here is at 0, 0. You can't get any y values less than 0, but it goes up forever. So the range is 0 to infinity. Okay, now that's our baseline. Let's try transforming this parabola. Let's look at this guy here. So this is f of x equals x minus 2 squared. So it's been shifted to the right. Our lowest point is now here where x equals 2. So the domain is still negative infinity to infinity because it goes both directions forever. And the range, again, is the same. We can't get lower than 0 for our y values. So range is 0 to infinity. All right, let's try a vertical shift. Vertical shift. So this is f of x equals x squared plus 3. So now, notice that the plus 3 is outside of the parentheses. So that means we shift up. So now our domain is still all real numbers, But our range, look, now our lowest y value is at 3. So the range is 3 to infinity. Let's do one more. How about this? Interesting. This is f of x equals negative x squared. So now, has the same domain. Any x value we pick has a y value. That's good. So the domain is negative infinity to infinity. But the range, look at this. Now the lowest y value we can get, well, we can go down forever. So it's negative infinity. But the highest y value is 0. Okay, hope that helps. Thanks for watching. Did you know you can combine functions? Let's say we have f of x equals x plus 2, and then we have g of x. It's my favorite letter for a function, g. All right, g of x is x squared, and we want to combine them some way. We could add them together, subtract them, multiply, divide. So let's say that, we'll say x equals 3. Okay, so then what is f plus g of 3? Well, first let's take f of 3, then we'll take g of 3. So f of 3 equals 3 plus 2, which equals 5. And g of 3 equals 3 squared, which equals 9. So f plus g of 3, we just add them together. 5 plus 9 is 14. How about f minus g of 3? That's 5 minus 9. That's negative 4. And then how about f times g? So f times g of 3. 5 times 9, that's 45. And I think you get the idea here, right? Let's take f divided by g of 3. Well, that's just 5 over 9. So that's one method of doing this. The other method is to just combine them first, combine the formulas. So we could say f plus g of x equals, well, we take f of x, which is x plus 2, and g of x, which is x squared, and we just add them together. So that'd be x squared plus x plus 2. And we can do f minus g of x. And let's see, that would be x plus 2 minus x squared. X plus 2 minus x squared. And so on. Now the one you have to be careful with is f divided by g. If g equals 0, you can't divide by 0. But yeah, hope that helps. Thanks for watching. Can you plug one function inside of another? Well, that's what function composition is all about. So let's say we have f of x equals x plus 2, and g of x equals x squared. So f of g of x, that's the notation we use. It's the same as this, f of g of x. So that means you do g first, and then you plug that result into f. So let's do an example. Let's take f of g of 3. So we can do g first. We'll say g of 3 equals 3 squared, which equals 9. And then we take that 9 and we plug that into f. So it'll be f of 9 equals 9 plus 2, which equals 11. So f of g of 3 equals 11. Okay, so another way of doing it is to just write the formula for f of g of x. So you start with x squared and you put that inside of f. So f of g of x equals, well, what's g of x? X squared. So we put that inside of f. We take f of x squared. and that equals x squared plus 2. Okay. And then, so if we wanted to do it that way, we could say f of g of 3 equals 3 squared plus 2, which equals 9 plus 2, which is 11. All right, and then another way of doing this, we can switch the order around. We could say g of f of x. G of f of x. That means you do f first. So f of x is x plus 2. We know that already. And then g of x is x squared. So g of f of x equals x plus 2 squared. So notice how f of g of x is not equal to g of f of x most of the time. So there's a different order, which means there's a different output. Okay, hope that helps. Thanks for watching. Is there a way to undo what a function does? Yeah, it's called an inverse function. Let's talk about it. So let's say you have f of x equals x plus 5. So a function takes an input and gives an output. An inverse function does the opposite. It takes that output and returns you to the original input. So this function here adds 5. So the inverse should be subtract 5. So f inverse of x equals x minus 5. So let's check it. So f of 3, well, that's just 3 plus 5, which equals 8. And now how about f inverse of 8? Well, 8 minus 5 is 3. So it perfectly undoes the original function. So let's talk about how to find the inverse function. So let's use an example, f of x equals 2x minus 1. So you replace the f of x with y equals 2x minus 1, and then you swap the x and the y. So x equals 2y minus 1. And then you just solve for y. So let's see, how can we do that? Well, you add 1 to the other side, then divide by 2. So y equals x plus 1 over 2. So f inverse of x, we just rewrite it, equals x plus 1 over 2. Okay, so let's check it. Let's use this function that we created. So f of 7 equals 2 times 7 minus 1, which equals 13. And f inverse of 13 equals 13 plus 1 over 2, which equals 7. Perfect. Perfectly undid it. Now let's just talk real quickly about functions that don't have inverses. So if the function, if you graph it and it looks, I don't know, maybe like this, what you can do is you can draw a horizontal line anywhere on this graph. And if the horizontal line passes through the graph in more than one place, in this case it passes through it 3 times, then it does not have an inverse. It is not considered one-to-one. So, but if it looked maybe like that, and we did a horizontal line there, it only passes it once, so it does have an inverse. Okay, hope that helps. Thanks for watching. Here's everything you need to know about functions. So we'll use f of x equals x squared. What does that mean? So it's a function. It means you put in x and it squares it. You get x squared out of it. So examples, f of 3 equals 3 squared, which equals 9. Okay, f of negative 2 equals negative 2 squared, which equals 4. Okay, how about combining it? Well, let's say we have g of x equals x plus 1. Well, then we can take f plus g of x, and that equals x squared plus x plus 1, which equals x squared plus x plus 1. And you can do that with subtraction, multiplication. Division, you have to be careful not to divide by 0. So how about composition. What if we take f of g of x? Well, that's f of g of x, which equals f of x plus 1, which equals x plus 1 squared. And if you do the math here, you'll get x squared plus 2x plus 1. Okay, let's try to graph it. You could plug in a bunch of points and see where they come out, or if you just know what a parabola looks like, it just looks like that. So the domain, what's the domain of this? So it stretches to the left and to the right forever. So you can find any x value you want, and there's a corresponding y value. So the domain is all real numbers, negative infinity to infinity. How about the range? The range are the possible outputs. So the possible y values, well, as you can see, it doesn't go below 0. So 0, but it goes all the way up to infinity. Okay, that's domain and range. How about transforming? There are a bunch of ways you can transform, but let's look at reflection. So negative f of x equals negative x squared. And we can graph that like this. It just flips it like that. Okay, so one more thing we'll do is the inverse. So this does not have an inverse because, as you can see, it fails the horizontal line test. But if you restrict it to x is greater than or equal to 0, then it'll just look like this. And that has an inverse. You can find that by replacing, you can take y equals x squared, switch the x and y, x equals y squared, solve for y, you get y equals square root of x, and that looks like that. Okay, hope that helps. Thanks for watching.